autoimmunity because it's a long topic and I don't want to mix this topic with other topics. So, autoimmunity, it means antigens against yourself. It means antibodies against yourself. Antigen is just a piece of your material, your proteins, your self. Okay. So there are two type of tolerance, right? So your body can tolerate your own shit, okay, and it has to tolerate, because if it doesn't tolerate, it means it's gonna attack yourself, okay. So what is antigen? First of all, what is self antigen? The word self antigen means yourself. So a normal body component that the immune system could target but ignores due to tolerance. Why? How it has tolerance? It has tolerance because it has gone through some things like positive selection, negative selection. It has gone through something called as peripheral tolerance. It has gone through something called as regulatory CD4 system, okay, and there is something called as bystander reactivity. So let's build on this concept and let's try to understand what this autoimmunity is really. So when I say autoimmunity, it means itself and immunity against itself, right? So what happens generally, the story time, right? What is overactive immunity? What is overreactive immune system? So what happens is that you guys have immature T cells, right? And these immature T cells are from thymus, right? And then you guys need CD4 cells and CD8 cell for education. These T cells go to them and they get educated on what to attack and what not to attack, right? What happens is that these are made in bone marrow, the immature T cells, then they go to thymus for education, and then blah blah blah. What happens is that in this thymus, they have two tests. One test is positive selection, one test is called negative selection. So what positive selection is that it happens, this positive selection happens on the cortex. It means on the outside body of the thymus. And this negative selection happens in the medullary part. It means in the central part. It's not central, but it's in the medulla. It's not cortex, okay? Let's talk about selection, positive selection. What happens in positive selection is that these T cells receptors, they recognize something called as self MHC molecules, right? So what are these words? First of all, T cell receptors mean T cell just receptors, right? They have receptors, and they have receptors for MHC molecules. What is MHC? MHC is just this serving plate for T cells, okay? Serving plate, and what is on this plate? Some sort of antigen or some sort of peptide, right? This is this plate where they serve, where they show it to the T cell, okay? So can TCR recognize self antigen on the MHC? This is positive selection. The negative selection is, it's a process by which TCR binds to self antigen or self peptide, okay? Self peptide means it's a part of your own machinery, right? So these self peptides, they come from part of your endocrine bodies, part of your endocrine system, from for example pancreas. So pancreas is both exocrine and endocrine, right? So if a peptide is served on MHC plate, okay, and this T cell tries to talk to it and understands it and recognizes and binds too strongly, it means it has failed this selection test, okay? So what happens in positive selection? Let's see. So there is entry, right? They enter into the cortex of they enter into the cortex. What happens that precursor T cells, they are double negative. It means they are CD4 negative and CD8 negative, okay? So T cells, precursor T cells are CD8 negative. It means they are not activated yet, okay? They need to get activated. How will they get activated? They'll get activated with the help of a second signal plus an antigen plus MHC molecule. We need these three things to get them activated. So as soon as they get activated, they rearrange their TCR genes and they'll get activated. So they become double positive CD4 and CD8 positive thrombocytes. Okay, so once they done the entry, they become activated. After this activation, they go through something called as positive selection. In this positive selection, the TCR tested against self MHC molecule. So CD4 are served with MHC 2, and CD8 are served for MHC1. All right. So they are given this plate of antigen, right? The food is served on this plate. What is the food? The antigen. What happens is that these precursors T cells, after getting activation CD4, CD8, they get tested against this self, and if there is no binding to the self antigen, it means it doesn't even recognizes it, right? It has to recognize it. It's really stupid. It has to. So death, apoptosis. Another thing is weak binding. So self antigen given to CD4, CD8, it recognizes it, it binds to it. All right, it recognizes, it's smart, so it recognizes, binds to it, so it survives. But the binding is really weak because it knows it's a self antigen. It's not a exogenous or any foreign antigen, right? So it's a weak binding. So it's a good news for our body. If it reads this antigen on MHC1 molecule, it means this CD is a CD8 T cell. If the T cell, the precursor T cell, reads the antigen on MHC2 molecule, it means it's a CD4 positive T cell, right? It becomes. All right. After this positive selection, we have something called as negative selection. Now in this negative selection, on MHC plate, on MHC molecule, the CD8 and CD4 is given a self peptide. What is a self peptide? Well, a self peptide is just a normal peptide, a normal part of your paracrine, endocrine, exocrine, all the crine body part. It's a peptide, it's a protein, it's a part of your protein. That's it. It's a part. It's your own protein. It's a sample of body's own protein, which is served on MHC to CD4 and CD8 molecules. Now, once it is served hot, what happens is that if the T cell overreact, it goes to death, apoptosis. If it doesn't go, if apoptosis doesn't happen, when, for example, sometime estrogen can interfere with apoptosis. So what happens is that it prevents something called as, so the whole process, it prevents autoimmunity, right? So if you guys do not have a lot of estrogen, if a woman has a lot of estrogen, so it can result, it's a theory, it's not proven, so it can result in autoimmunity. So that's the result. So if there is strong binding with the self peptide, it should be death, goes to apoptosis. If it's a weak binding, it means the news is really nice. Your CD8, CD4 cells, they recognize the self peptide and their binding is really weak. It's not attacking it, so it survives. Okay, so there is something called AIRE gene. This gene represent many tissue specific peptide or antigen. This is the gene that take cares of this serving part, right? This gene serves the self peptide on the MHC part, on the MHC molecule to CD8 and CD4. What happens after this? If you guys have any sort of mutation in autoimmune, this gene AIRE gene, you'll have something called as autoimmune polyendocrine syndrome, because these self peptides are taken from the endocrine system of the body. So we'll have something called as AIPS syndrome. And what happens is that this is a self-reactive lymphocyte attacking the endocrine system of your body, right? The result of this whole positive and negative selection is that there is a single positive. It means either it's CD4 positive or a CD8 positive. And then they leave the thymus, right? The cortex part is positive. The medullary is the negative part. Then they go to lymph or the blood, right? So this was positive selection and negative selection. That's how the body trains the CD8 and humoral immunity is trained in negative selection and positive selection. Okay. Now there is something called as peripheral tolerance. What is peripheral? Peripheral means around. Tolerance is tolerance. So what happens is that there is something called FAS molecule. FAS molecule. Now this molecule binds to something called as a FAS receptor. And now this receptor is also called CD95. It is like this, right? So if on the periphery a molecule shows a fast ligand, that is this ligand is something which binds to the receptor, and then this molecule has another molecule has something called a CD95 receptor, what will happen is apoptosis. So fast apoptosis is a pathway. It's an extrinsic pathway. It's not intrinsic, it's extrinsic. So this fast apoptosis pathway happens if there is any sort of mutation. What will happen is that there will be some autoimmune lymphoproliferative syndrome. Why proliferative? Because the fast pathway is not happening. The apoptosis is not happening. So what happened that naturally fast should bind to CD95 receptors, but the binding is not happening. There is some sort of mutation. Apoptosis is not happening. Lot of lymphocytes, lot of proliferation. And these lymphocytes, these naive lymphocytes, they make IgG. And then you'll have something called as IgG immunoglobulin against the cell in your blood. So this is the concept of peripheral tolerance. Another concept is regulatory CD4 positive cells. Regulatory cells, not CD4 positive, regulatory cells. In this regulatory cell, we have three types of cells: CD4 positive cells, CD25 positive cells, and FOXP3 gene. It's a gene. Okay. What happens is that I told you for the activation of CD4 and CD8, we need antigen plus MHC molecule plus a secondary signal. Not secondary, second signal. Second signal is the permission signal. Once you can block the second signal, it means the permission to mutate, the permission to class change, the permission to change your class, from IgG to IgM or to IgE never happens. Once this second signal stops, you can suppress the autoimmunity. So CD4 lymphocytes, they can suppress the immune cells and they can maintain the tolerance by secreting something called as CTLA4. Now, once these CD4 cells express this CTLA4, they bind to B7. Now, B7 is the second signal for CD4. Once B7 is binded, it shuts down the second signal. No activation of CD4 cells. What happens? Energy. What is energy? Energy is just when the CD4 completely shut down and go to a deep sleep state. That's called energy. Another way we can shut down the second signal is by secreting IL-10 and TGF beta. What is TGF beta? Tumor growth factor. TGF beta. Now this TGF beta, we have something called as TGF gamma and TGF beta. Gamma is for the gamma is for growing macrophage. G is green, TGF gamma. So for macrophages. So TGF gamma makes macrophages. TGF beta is the opposite of it, right? So TGF beta decreases macrophage. TGF beta decreases MHC molecule. And IL-10 is, we know, it suppresses TH2. No, not TH2. TH1, right? It's anti-inflammatory. It produces cytokines that inhibits TH1. So now we know CD4 regulatory, CTLA4 energy. Another thing is called polymorphism. It means changing the morph, like changing. So it means mutation of CD25. What is CD25? CD25, it's a part of interleukin-2 receptor molecule. What happens is that CD25 is also a regulatory. It's a part of regulatory system. So CD25 goes to mutate. You cannot perform this shutting down of second signal. You'll have autoimmunity. Another thing is FOXP3 mutation. What happens in FOXP3 mutation is that It's a transcriptional factor for these genes, regulatory cells, not genes. Once FOXP3 is messed up, you'll have something called as IPEX. It's an autoimmunity disorder as well. So FOXP3 polymorphism of CD25, CD4 regulatory cell, negative selection, positive selection. Now we understand this thing, right? How the body is trying to not attack itself. Another thing is bystander reactivity. What happens is that bystander means on the side. This is the main show happening. For example, reporters, press, these are bystanders. Whatever happened, they bystand this whole thing. So bystander reactivity, what happens is that T cell get activated without directly recognizing any sort of antigen. So non-specific antigen activation of T cells, it's called bystander reactivity. And what happens is any sort of environmental shit, for example, cytokines, any sort of environmental stress can activate this T cells non-specifically. And once they are activated, they start, destroying your own self. So activated by some environmental shit, for example, molecular mimicry. One bacteria, it can make something called as M protein, and this M protein can mimic this whole, your antigen, self antigen. Once it mimics, your mitral valve is messed up. There's endocarditis and mitral valve is messed up. So this is the whole function of molecular mimicry. Molecular mimicry happens via bystander reactivity. So this was the little bit concept about how autoimmunity really works.